Welcome you all. I'm Dr.M.Tamilselvi, Assistant Professor, Department of Chemistry, Sita Lakshmi Ramaswamy College. In this video, we are going to discuss the topic ionic and covalent compounds. Firstly, we are going to see the definition of bonding and look into its important types. Then we are going to state and explain the octets rule. Later, we are going to discuss the naming, physical properties and uses of ionic compounds. Followed by which we are going to understand the Lewis dot structure, and towards the end of the presentation we are going to elucidate the naming and uses of covalent compounds. Bonding is defined as the joining of two atoms in a stable arrangement. Only the noble gases in group 8A do not readily react to form bonds because the electronic configuration is especially stable. Whereas all the other elements will gain, lose or share electrons to attain the electronic configuration of the noble gas which is closest to them in the periodic table. There are two main kinds of bonding. Number one is ionic bonding. Ionic bonds result from the transfer of electrons from one element to the other. Number two is a covalent bonding. And covalent bonds result from the sharing of electrons between two atoms. So in general, an ionic bond is formed by a metal on the left side of the periodic table with a non-metal on the right side of the periodic table. As we see in the slide right here, sodium metal reacts with chlorine gas to form sodium chloride, which is an ionic compound. The octet rule states that a main group element is especially stable when it possesses an octet of electrons or 8 electrons in its outermost shell. We all know that an atom is going to form a cation by losing electrons, and it is going to form an anion when it gains electrons. So here we have the periodic table showing the ions formed by the main group elements. So groups 1A, 2A and 3A, which contain the metals, are going to have the charge corresponding to the group number. Whereas the non-metals present in group 6A and 7A are going to have the charge corresponding to 8 minus the group number. So 6A is going to have a -2 charge and 7A is going to have a -1 charge. The elements which are present in the center of the periodic table, which exhibit variable valencies, are also shown in the slide right here. Now, talking about the naming of ionic compounds, first the cation is named and then the anion. So if you have NaF, it is going to be called as sodium fluoride. MgCl2 is called as magnesium chloride. Whereas if you have a variable valency element like CuCl2, then it is going to be called as copper 2 chloride or cupric chloride. So talking about the physical properties of ionic compounds, they are crystalline solids that have very high melting points and very high boiling points. And these ionic compounds, they dissolve in water and separate into cations and anions. This property helps it to conduct electric current. So talking about the uses of ionic compounds, they have a wide variety of applications. They are used in the antacid tablets as iron supplements, as common salt and in toothpaste, and also in baking soda, bleach, washing soda, etc. Now we are going to see the covalent bonding. Covalent bonds result from the sharing of electrons between the two atoms. So if we look into a hydrogen molecule, H2, there are two electrons which are shared in that covalent bond. Okay, so now we have also something called as lone pair of electrons. They are nothing but the unshared electron pairs. So in general, if you look into the periodic table, hydrogen shares 2 electrons and it's going to be happy if it's going to attain a duet. Whereas all the other main group elements, they are going to be stable when they possess an octet of electrons, that is 8 electrons in their outermost shell. So talking about the naming of covalent compounds, we have two examples right here, NO2 and N2O4. The first compound, NO2, is called as nitrogen dioxide, whereas the second one, N2O4, is called as dinitrogen tetroxide. So the prefixes mono, di, tri, tetra, etc. are very important while we name the covalent compounds. So covalent bonding and the periodic table, if we look into, we find that covalent bonds are formed when two nonmetals combine or when a metalloid bonds to a nonmetal. And the predicted number of bonds is going to be equal to 8 minus the number of valence electrons. So this is the picture of Professor Gilbert and Lewis, who introduced the Lewis dot structures. He was nominated for the Nobel Prize for about 41 times. And this great scientist proposed that Lewis dot structures reflect the electronic structure of the elements. So here in this table, we find that hydrogen, which has one electron, is always going to form one single bond. Whereas carbon, which has 4 valence electrons, is going to always form 4 bonds. Then if we look into nitrogen, which has 5 valence electrons, it normally forms 3 bonds. And oxygen and sulfur, which have 6 valence electrons, normally form 2 bonds. And halogens, which have 7 valence electrons, always form a single bond. So talking about the uses of covalent compounds, they are found in the sugar crystals and the vinegar, and then the air, which is composed of a variety of gases like carbon dioxide, sulfur dioxide, etc. And then we have the LPG, which is composed of butane, propane, etc. And the nail polish remover, which contains the acetone. Diamond is also having covalent bonding present in it, and the plastic bottles we come across. So there is a wide variety of applications and uses for covalent compounds. So in this presentation, we have looked into the two types of bonding, ionic bonding and covalent bonding. Ionic bonds result from the transfer of electrons from one element to the other, whereas covalent bonds result from the sharing of electrons between two atoms. The octet rule states that a main group element is especially stable when it possesses 8 valence electrons. In ionic compounds, the cations are named first and then the anion. The ionic compounds are usually solids and they have uses in medicine, household products, etc. Lewis dot structures reflect the electronic structure of the elements. And towards the end of the presentation, we have recognized the uses of covalent compounds, and we have also looked into the naming of covalent compounds. Thank you for your patient listening.